In this video, we will discuss about implementation of 4-bit parallel adder or subtractor using 4 full adder block. So in one of my video, already we have discussed about full adder circuit, and we know that full adder is a circuit which adds 3 binary bits. For example, suppose if I consider this as a full adder, so full adder has 2 inputs, say A and B. It has another input, that is carry input, and it produces 2 output. One is sum and another one is carry out. So now if we use this full adder block, it can be used only as a adder. Now I will modify this full adder block such that this can be used for adder as well as for subtractor. The modified circuit, so this is the modified circuit which looks like this. So here I will assume that this is full adder. So let me consider this as A input, this as B input. Here this I will consider it as C in, and this is sum output, and let this be my carry output. So here if we compare this block with this block, we can see that the input given to the B input given to block is passed through XOR gate. So here B input is not directly given to the full adder block, but it is passed through XOR gate. So one of the XOR gate input is B, another input is C in, as we have connected here. Now let me explain you that how it works. So let me consider A is equal to 0 and B is equal to 1. So in this circuit, the C in pin acts as a control pin. That is, if C in is equal to 0, then this circuit acts as adder. Similarly, if C in is equal to 1, then this circuit acts as subtractor. Let me explain that. So here let me consider A equal to 0 and B equal to 1, and let me take C in equal to 0. So in first case I will take C in equal to 0. So as I said, when C in is equal to 0, it acts as an adder. Let me verify that. So when we give C in here, this C in we have taken it as 0. So one of the input for the XOR gate is 0. So here we have assumed B equal to 1. So this is 1 and A is 0. So this is 0 given to the full adder block. Here we can observe that when any one of the input of the XOR gate is 1, then output is 1. So here output is 1. So now 1 will be added with 0 and it will be added with 0. That is nothing but full adder, because so here 0 plus 1 plus 0, it produces sum as 1. So it is sum is equal to 1. So thus it acts as an adder when we considered C in equal to 0. Now let me take C in equal to 1. That is, I will take the same inputs, that is A is equal to 0, B is equal to 1. Now I will consider C in is equal to 1. So let me analyze in that case. So now I will take C in equal to 1. So now this 1 will appear here. This will become 1. So now this A is as usual 0. So here now both the inputs of XOR gate is 1. When both the inputs are equal, then output of XOR gate is 0. So here output is 0. So same 0 is applied to full adder. Now 0 plus 1, that is 0. So the B input we had given it as 1, but it is taking now it as 0. That is 0 plus 0 and C in plus 1. So it produces sum. So here sum is equal to 1. So now it is acting as subtractor. Let me verify the same thing. That is, here I have taken A equal to 0 and B equal to 1. That is, A equal to 0, B equal to 1. If we do the subtraction, that is 0 minus 1, we know that it produces the result as 1. So this one and this one are same. So thus this C in Depending on the Cin value, this circuit will act as either adder or subtractor. That is, if Cin is 0, it acts as adder, and if Cin is 1, it acts as subtractor. So according to the problem, we have to implement 4-bit parallel adder or subtractor using 4 full adder block. So now to implement this 4-bit adder, we have to use 4 same kind of blocks. So now let me connect 4 same kind of blocks. So all blocks I will connected in series or cascaded form. So now this is the 4-bit adder or subtractor. So let me call this as full adder 0. I will call this as full adder 1. This is full adder 2, and this is full adder 3. So here let me assume this is Cin as I have shown in previous circuit, and let me call this as A0 input, this is B0, this is A1, this is B1, this is A2, and this is B2, and let me call this as A3 and this as B3. So similarly, it produces S0, S1, S2, S3 as some output. So Cin is the first carry input to the first full adder. It produces the carry out. I will call it as C1. So this C1 acts as a carry input for next full adder. It produces carry out. I will call it as C2. It acts as input for the next full adder, and it produces C3, which acts as input for the next full adder, and finally the final carry I will represent it as C out. So this circuit will act as 4-bit adder or subtractor. So here if we consider Cin equal to 0, it acts as 4-bit adder, and if we consider Cin equal to 1, it acts as 4-bit subtractor. Let me take, so now let me consider A3, A2, A1, A0 as say 0, 1, 1, 0, that is A bits, and I will consider B bits, that is B3, B2, B1, B0 as say 0, 1, 0, 1, that is B is 0, 1, 0, 1, that is nothing but 5, and A we have 0, 1, 1, 0. So here we can observe that Cin we have considered it as 0. This 0 will go to here. So this is 0, this is 0, and this is 0. Here both the inputs of XOR gate is same. So output is 0. Here one of the input of XOR gate is 1, another input is 0. So output is 1 here. So here again it is 0. So again it is 1. So in here input to the full adder is 0. It is 1 here. It is 1 here, and here it is 0. So now here we can see that 1 plus 0 plus 0, it produces sum as 1 and produces carry as 0. So this carry will act as input for this. So now in this full adder 0 plus 1 plus 0, it produces sum as 1 and carry as 0. So now here 1 plus 1 plus 0, that is 1 plus 1 is 0, 0 plus 0 is 0, and carry is 1, that is S2 will be 0, and it produces carry as 1. This carry acts as input for this. So here 0 plus 0 plus 1, it produces sum as 1 and final carry as 0. So now the result is 1, 0, 1, 1. Result is, that is S3, S2, S1, S0 is 1, 0, 1, 1, which is nothing but 11. That is, here we have 6, this is nothing but 5, 6 plus 5 is nothing but 11. So now we can say that this circuit is perfectly working as 4-bit adder. Now let's see how this circuit will act as 4-bit subtractor. So now let me explain how this circuit acts as a subtractor. So let me take Cin equal to 1. I will consider Cin equal to 1 now. So if we consider 1, so this 1 will appear here, this 1 will appear here, this 1 will appear here, and this 1 is appear here, because one input of all XOR gate is connected to scene. All are shorted as I have shown here. So now here one of the input, both the input of this XOR gate is 1 1, this output is 0. Here one input is 0, another one is 1, so output is 1. So here it is 0, both inputs are same, here output is 1. So now let me analyze. So here we can see that 0 plus 1, it produces some output as 1, carry output as 0. So this 0 will go here. 1 plus 1 plus 0. So 1 plus 1 is sum as 0. That 0 plus 0 is 0 and produces carry as 1. So here it produces carry as 1. So this 1 acts as the input for this. So here 0 plus 1 produces sum as 0, again carry as 1. So this 1 acts as input for this. So here 1 plus 0 plus 1 produces sum as 0 and final carry as 1. So now here we can observe that if we concentrate on sum, it is 0, 0, 0, 1. That is 0, result is 0, 0, 0, 1. So 6 minus 5 is nothing but 1, that is 0, 0, 0, 1. So we should ignore this final carry, then the result will be 0, 0, 0, 1. So 6 minus 5 is nothing but 1. Let me subtract this, that is 0 minus 1 is 1, borrow 1, 1 minus 1 is 0, 1 minus 1 is 0, that is 0 minus 0 is 0. So here we can see that A minus B produces output as 0, 0, 0, 1. So with this circuit we got 0, 0, 0, 1. So here basically this circuit will perform subtraction using 2's complement addition. So here the function of XOR gate is, the XOR gate will perform 1's complement of input B, because here we can see that 1, it produces output as 0, that is 1's complement of 1 is 0. So 1's complement of 0 is 1, 1's complement of 1 is 0, 1's complement of 0 is 1. So the XOR gate will perform 1's complement of the input B. That 1's complement will be added with Cin, because Cin is equal to 1. So 1's complement 1 is 1's complement plus 1 is nothing but 2's complement. So 2's complement B will be added with A. So let me calculate this manually. So here A value will be kept as it is, that is 0, 1, 1, 0. I'll take 1's complement of B. So 1's complement of B is 1, 0, 1, 0 plus 1, because this Cin is connected to all the full adder. So it produces 1, 1, 0, 1. Now add this result with this result. That is nothing but 2's complement addition. That is, so here we can observe that the output of XOR gate is 1, 0, 1, 0. That is nothing but 1, 0, 1, 0. That is 1's complement plus 1. That plus 1 is nothing but Cin, as Cin is given to all the one of the input of XOR gate. So 1's complement plus 1 is nothing but 2's complement. So this is 2's complement of B, that will be added with A. That is 0, 1, 1, 0 is added with 1, 0, 1, 1. Now let me add these two. 0 plus 1 is 1, 1 plus 1 is 0, carry 1, 1 plus 1, 0, carry 1, 1 plus 1, 0, carry 1. Ignore this carry. The result will be 0, 0, 0, 1, which is nothing but 0, 0, 0, 1. Both are same. Thus, this circuit perfectly works as 4-bit subtractor when Cin is equal to 1. Now I can conclude that when Cin is equal to 0, this circuit will act as 4-bit full adder, and if Cin is equal to 1, it performs 4-bit subtractor. The subtraction is done using 2's complement addition. Thank you for